Okay, this is 2.7, 2.8 notes. We're going to start with combining functions. So let's say we start with f of x is equal to x squared and g of x is equal to x minus 3. And let's start with, this is how you read this, f of g of x. And so we're going to take, I'm going to take my f and I'm going to plug in g of x. So this would be x minus 3. And then we're going to take x minus 3 and plug it into my f function. So I'm going to say x minus 3, and I'm going to square it. And a lot of y'all are still doing this. It's killing me here. Take your x minus 3, that means take this quantity and double distribute it. That would give you x squared minus 6x plus 9. And this would be my answer. Now let's go backwards. And I'm going to say g of f of x. So I'm going to take my g, plug in an f of x right here. So that would be x squared. So now look at your g function, and for every x value, plug in an x squared. So this would be x squared and then minus 3. And it looks like that is your final answer. Okay, this says the domain of f of g of x is the intersection of the domains of g of x and f of g of x. So what this means here, and you've heard these words before, this is your input, the g of x, your output or your answer is going to be the f of g of x. Okay, so it says let f of x equal the square root of x, g of x equal the square root of 2 minus x, and find g of f and its domain. This means g of f of x. Okay, these are the same things. And I'm going to go ahead and write this one up here. You're going to see this as fog. All right, so if I want to find g of f of x, take your g, plug in your f of x function first. So I'm going to take my square root right here, and I'm going to plug this in for every x that I have into your g function. So this would be the square root of 2 minus, and for every x, plug in a square root of x. And that's what my function would look like. Now it says find the domain. So this is what I would do. I would find this domain first. So this domain, remember when you find these, you just take it out and find it greater than or equal to 0, 0 to infinity. Then if we find the domain for this problem right here, take it out of the square root again. So this would be 2 minus the square root of x is greater than or equal to 0. Looks like we need to square both sides, or if you flip it around, x is less than or equal to 4. So I'm going to take both of these answers and combine them and graph them. So if you graph them on a number line, I'm going to start with this and go from 0, because this is what my original was. Start with 0, close my circle. I would go to infinity, but my combined function is going to make me stop at 4. And I'm going to close that circle and I'm going to shade in between. And that would be my graph. On number 3, if h of x is equal to the fourth root of x plus 9, find f and g such that h of x equals the f of g of x. So basically, I want to find out what f of x could equal and what g of x could equal so that I get this combined function. And remember, you might see it written as fog. There's several ways that you can come up with this. I'm going to do it the most basic way that I can. So if I need to plug g of x into f, I'm going to make g of x equal x plus 9. And I'm going to make f of x be the fourth root of x. So I could plug g of x, x plus 9 into this, and it would give me this as my result. So if you want to try this one on your own, there's a couple of ways to do this. Again, I want to know what f of x could be and what g of x could be in order to get a combined function that looks like this. So we need to do g of x first. how about if I do x squared minus 8, then I can make f of x 5 over x. Or how about making g of x, I could just make this x squared. Then I could put the fraction here and say this is 5 over x minus 8. So you can see there's a couple of ways that you could set this up. All right, let's look at inverse functions. If f of x has a domain A and range B, then the inverse x, or the inverse of f, has a domain B and range A. The graph of the inverse of f is a reflection of f of x across the line y equals x. If f and g are inverses of each other, then f of g of x is equal to x, and g of f of x is also equal to x. F of 1 equal to 5, f of 3 equal to 7, and f of 8 equal to negative 10. If I give you the inverse, or say the inverse of f is 7, so I'm basically asking what gave me 7, and what gave me 7 was 3. On B it says the inverse function gave me 5, so what gave me 5? That was 1. Okay, if I give you a function and I want to find the inverse, remember this is really y, so I'd say y equals x to the 5th minus 3 over 2. Now go ahead and switch your x and y. So this is really x equals y to the 5th minus 3 over 2. So I'm just switching my x and y. Now solve for y. So let's see, this is 2x equals y to the 5th minus 3, add 3. Looks like we need to take the 5th root in order to get rid of this. Gets rid of your y to the 5th. So that means I need to go over here as well. So y to the 5th root gives me y. And then this right here is going to be my answer. So it's going to be to the 5th root. So 2x plus 3. Okay, this right here is the most important thing. It says find the inverse. Remember, or in order to write your inverse, you say f to the negative 1 of x is equal to the 5th root of 2x plus 3. This would be my final answer. I have a lot of people put this as my final answer and it just says y equals. I will count off for that. So make sure you say the inverse function is equal to your answer. If you would like to try this one by yourself and then check it with mine, go ahead and pause the video. So I'm going to say y equals and do your x minus 2. But I'm going to switch my x and y. I'm going to square both sides. So this is x squared equal to y minus 2. Then solve for y. So this is x squared plus 2 equals y. This one's really easy. Again, my final answer, the inverse function of x is equal to x squared plus 2. This one I wanted to go ahead and show you a graph of. It's a little bit different. And the only reason I'm saying it's a little bit different is because this right here, the square root, it's shifted over and it's square root. So basically I have square root function shifted over. So it looks like this. I have y equals x. A really bad line, but this is y equals x. Remember, if you do your inverse, it's flipped over the y equals x line. So if I were to flip this line over, basically looks like this. I'm not sure I can flip this. There we go. So it looks like this. Here's your line reflected over. So here's x squared plus 2. Well, I know x squared plus 2 is a parabola. So if I just want this reflection, then I need to say that this is the inverse only if x is greater than or equal to 0. And I knew there was going to be a restriction because I had a square root. All right, the last part of the note says a graph is said to be 1-to-1. This is something you need to know. 1-to-1 if there is no repeated x values. That means it's going to pass the vertical line test. And no repeated y values, meaning it passes the horizontal line test. So if f of x is 1 to 1, then the inverse function is also a function. So I'm just going to answer these according to this graph. There are arrows on the end, so it keeps going. So is the graph to the right 1 to 1? This is no. Is the function, is this regular function a function? So you could do the vertical line test this way. This is a function, but is the inverse, so meaning you could do a horizontal. So if you did one this way, this is not a function.